Today we're going to talk about resistors, and they are the most common thing you will see in your electrical engineering career. So there's a few ways that they're written out. This first one here, which is the most simplest one that I use. The second one here takes more time to draw, that's why I use the first one. And the third one is just a box with wires going in and out of it. It's used in many older designs that I've seen. Recently, I really just see the first two, but the third one does exist. So resistors are used to limit the current in a circuit, and their unit is the Greek letter omega, and it is symbolizing ohms. So typically, the resistors you will see look like this, where this little bead is your actual resistor, and then your wires are there. You may also encounter something that looks like this, where this is your resistor, and then you have two wire terminals which you can solder wire to. On the other end of the spectrum, you can also have these, which are very tiny resistors. So there's about maybe 20 or so in there. Each little black square is a resistor. And we express the resistance of one of these resistors as this formula right here, where the Greek letter rho is a material property known as the resistivity, L is your length of your material, and A is your cross-sectional area. The resistivity rho is equal to the inverse of sigma, which is known as the conductivity of the material. So there's a few combinations we can do for resistors. We will first cover two resistors in series and parallel. So if we have two resistors in series, they're just connected right to each other, so we can call this R1 and this R2. And what happens is the total resistance, we can express this as one single resistor, which is equal to R1 plus R2. And that is how you calculate resistance for two resistors or any amount of resistors in series. We also have something called putting resistors in parallel, which is when you have two resistors that are parallel to each other, but they are connected on the same node. So you could have R1 here and R2 here. We can also express this as one single resistor, which is equal to 1 over 1 over R1 plus 1 over R2. And luckily, we can express that if we have two resistors as R1, R2 plus R1, or divided by R1 plus R2. So we have resistors in series here and then in parallel here. If you have more than two in parallel, you would just throw the remaining terms of the inverses onto this sum here. So we can look at a simple question. Which of these two has more resistance? We have part A being two ohm resistors in series, and part B having two 2 ohm resistors in parallel. So given what's above, we can say that this is equal to 2 ohms plus 2 ohms, which is equal to 4 ohms. And this one is equal to 2 ohms times 2 ohms divided by 2 plus 2, which is our simplified formula that we found here for two resistors in parallel. Doing the quick math on this is equal to 1 ohm. So we see for the resistors in series, we have 4 ohms, for in parallel, 1 ohm. So part A, or option A, has more total resistance. We will cover more resistors next time and a lot more circuits.